Hello dear friends, welcome to GATE Academy Global. So before starting today's session, I would like to take the feedback or the concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go. My dear friends, the agenda behind the class which we used to held at 9 p.m. must be clear to all of us. And in the same series, we have reached to the 13th lecture of the engineering mathematics, where taking the reference of the problem which have come in GATE year of 2021, I am building the concept for the GATE year of 2022. So in today's lecture, I am going to take around 1 or 2 questions from the vector calculus, and once we are done with the vector calculus, straight away we will move it to the differential equation. Around 3 to 4 number of questions we are going to take from the differential equation, obviously which have appeared in GATE year of 2021. So before starting today's session, just a minute, before starting today's session, let me focus over the topic which we are going to cover in today's class. At very beginning, I would be taking few number of questions from the vector calculus. Once we are done with the vector calculus, I would be taking few number of questions from the concept of differential equation. Yes, tell me regarding the quality of audio and video. If it is perfect, just write perfect over the live chat. Anyways, let me move back. The first question is coming from my PDF, page number 23. Page number 23. So this is the first question which we are going to take in today's class. Yes, it has been a very well designed problem. May I know in which branch this problem has been appeared? This problem has appeared in civil engineering year of 2021 in afternoon session. You guys must be aware of it. The civil had the 2 session, forenoon and afternoon session. This problem was appeared in afternoon session. Try to read the problem carefully. Yes. GATE to 2021 result is out. Definitely Mukherjee. See what the problem states. A function is defined in Cartesian coordinate system as f, this is a function of x comma y, is equals to x into e to the power of y full stop. The value of directional derivative of the function in integer at point 2 comma 0 along the direction of the straight line segment from the point 2 comma 0 to the point 1 by 2 comma of 2 is, the options were given. See, it was a type of NAT problem. Anyways, before smashing this problem out, let me bring this problem into the working board, and there we'll try to smash this problem with the all reasoning. So let me bring it to the working board. Just a minute. Yes. Here goes the problem. Try to read the problem carefully and try to decode how we will solve this problem out. My dear friends, what this problem states, a function is defined in Cartesian coordinate system as, obviously it has been a Cartesian coordinate system because f has been a function of x, y, or in future even it could be a z if it would have been a 3D coordinate system. But anyways, in this problem one thing is quite sure, we have been dealing with 2D Cartesian coordinate system. Cartesian coordinate system. That means we are supposed to have 2 variables, maybe xy, maybe yz, maybe zx. Here it has been x and y. Similarly, you also had a function f which has been the function of x and y, which has been precisely given with your problem. The second data has been given as f, which is supposed to be function of x and y, has been given as x into e to the power of y. Now, if you'll start reading from this dot onwards, the value of the directional derivative. May I know what does it mean by the directional derivative? The directional derivative is same as gradient. So we had to find the directional derivative of this function. So let me focus over the third statement. It has been focusing over the directional derivative of function f of x, which is very same as the gradient. How the gradient is being written? It's a del or nabl of the function f, which is a function of x and y. How do we calculate this? Probably most of us must be knowing how do we calculate the gradient. The partial differentiation of f has to be taken place with respect to the x, and it would become a component of in the direction of ax cap. Similarly, dou f divided by f dou y, ay, and you need not to write the component in the direction of z, y, because the f has been a function of x and y alone. So in future, even if you will take the differentiation with respect to the z partially, the value would become 0. If you want, you can write no issue. If you want to write, you can write over here. There is no issue as such. No issue as such. Obviously, we had to take its differentiation with respect to the x first. If we'll take the differentiation with respect to the x first, my dear friend, it has been a partial differentiation. That means the y has to be treated as a constant while taking the differentiation with respect to the x. So the differentiation of x would be simply e to the power of y. So the factor which we have is simply going to be e to the power of y ax cap. Similarly, if we take the partial differentiation of the function x into e to the power of y with respect to the y, x would be treated constant, obviously it would be knocked off. The differentiation of e to the power of y with respect to the e to the power of y would remain very same, and that is nothing but x into e to the power of y, and here it goes ay cap. So the gradient, which is directional derivative of the function x and y, is clearly known to me. It's clearly known to me. Yes. Now, if you will start reading beyond further, what has been given of the function in integer at the point 2, 0. That means this directional derivative has to be precisely calculated over point x is equals to 2 and y is equals to 0. So what I would be doing over here, I would be calculating the specific value of the gradient of the function f of x comma y at x is equals to 2, y is equals to 0. Y is equals to 0. So let's start feeding the value of x as 2 and y as 0. Once we will be feeding y as 0, definitely it would become e to the power of 0. E to the power of 0 is 1. 1 would get multiplied with the ax cap. It would be just ax cap. It would be just ax cap. Similarly, the same process has to be followed over here. The value of x has to be fed as 2. E to the power of 0 would become 1. So the factor which would be coming out is simply going to be 2 into a to the power of a cap. So this has been the directional derivative of the function precisely at a point 2, 0. And obviously it has been a vector function. It has been a vector function. Yes, it has been a vector function. Now, one twist we had in this problem. See what it was. At the point 2, 0, along the direction of a straight line segment from the point 2, 0 to the point 1 by 2, of 2. 1 by 2, of 2. My dear friends, it has been a vector. For the better understanding, you can take this vector as a b vector. Obviously, it has been a directional derivative, but it has a vector. So you want the projection of this vector over another vector which starts from 2, 0 and lands up to the half comma of 2 and has been a straight line. Could you understand what I am saying? What I am saying, at very beginning you calculated directional derivative, which is a type of vector quantity, b vector. You want to get its projection over another vector quantity which has been a vector quantity joining between the 2.2, 0 and 0.5, 2. You can take that as a vector, and a vector has been the vector which has been joining the 2 point, which is nothing but 2, 0, and here it goes 1 by 2, of 2. You want to have the projection of this b vector. May I know whether you want the projection along with its direction or projection along with its unit vector, or only and only you want its projection? You want only and only its projection. How did you know about it? See, you yourself would be able to understand. It has been a numerical answer type of problem. That means you will be getting a numeric answer. Obviously, has to be a weightage of the projection. May I know how we solve this sort of problem? My dear friends, whenever we try to get the projection of one vector over another, I repeat, whenever we try to get the projection of one vector over another, what's the methodology we use? The projection of mod of b over the a vector would be mod of b into of cos theta. Could you understand what I am saying? Mod of b into of cos theta. Till this point, each and everything must be clear to all of us. Even the mod of b into cos theta can be easily calculated by taking the dot product between a vector and b vector. How? See, a vector dot of b vector used to be equals to of mod of a into mod of b into of cos theta, but as we have been interested finding only and only value of mod of b into cos theta at denominator, you had to take the determinant of a vector. You had to take the determinant of a vector, and once we take the determinant of a vector divided by the determinant of a vector can simply be written as unit vector over vector a dot of b vector. Dot of b vector. Whatever answer you get now, that would be the best most answer for this given problem. Could you understand what exactly I wanted to say? At very beginning, the problem was clearly given. In problem, you had a function f which was a function of x and y. You wanted to get its what directional derivative. That means you wanted to get its what gradient. Once the gradient is done, it has become a vector quantity. Now you want the projection of this vector quantity over a straight line which has been fabricated by joining the 2 points over the xy plane, that is nothing but the 2, 0 and half, 2. Yes, no? Yes. So now you had to find the unit vector over the vector a vector. This would be the unit vector. How will you get the unit vector? My dear friends, it is quite easy to get the unit vector. The a n cap would be at numerator, first you will be getting a vector itself, and at denominator you will be getting its magnitude. What would be the a vector? Final minus of initial. So the half is getting subtracted with the 2. It was a 0.5, 0.5 is getting subtracted with the 2, which would be minus of 1.5. Minus of 1.5. Similarly, the 2 would get subtracted with the 0. It would result plus of 2ay cap, and at denominator you will be having its magnitude. What would be its magnitude? It would be 1.5 square plus of 2 square. Plus of 2 square. Yes, plus of 2 square. Till this point, each and everything must be clear to all of us. Just focus over this factor. A n cap is known to me. Similarly, b vector is known to me. You will just take its dot multiplication. Hence, a n cap dot of b vector, a n cap has been here minus 1.5 of ax cap plus of 2 times of ay cap, and at denominator you will be having 1.5 to the power of 2, that would be 2.25. 2 square would be 4, so it would be 5.25. 5.25, yes, 5.25, and similarly it would get dot multiplied with ax cap plus of 2ay cap, and once you will take its dot multiplication. How the dot multiplication has to be taken place? The dot multiplication between the like unit vectors would be 1, ax dot of ax would become 1, and unlike unit vector would become 0. So end of the day you will end up multiplying minus 1.5 with 1, 2 with 2, and at denominator you will be having root over 5.25. Once you will be calculating it now, the answer which you will be getting, it's simply going to be 1. The answer which you will be getting is simply going to be 1. So the best most answer which we are getting for this problem is simply going to be 1. What does that mean by the answer is 1? That means the projection of b over a has been unity. That means if you will calculate its chord length or magnitude length, the magnitude length would be precisely 1. Precisely 1. Yes, I cannot say it is a difficult problem, because repeatedly this sort of problem has been coming for civil as well as mechanical engineering. So the student who have gone through the PY questions definitely could have smashed this problem with great ease. So just wanted to know till this process, if you guys are having any sort of doubt, you can put it over the live chat. Otherwise, we are ready to move into the next question. Yes. Process is known. Function we had, directional derivative we got a vector which is nothing but the directional derivative of the function. Now we had to get the projection of this vector over the vector a vector, which was a vector by joining the 2 points over the 2D plane 2, 0, half, 2. You got the each and everything. So till this point probably each and everything must be clear to all of us. In the same sequence, let me move forward and let me take the next question. The next question comes from the page number 11. Just a minute. Just a minute. Yes. This would be the next question. If we'll talk about the property of this problem has appeared in electronics year of 2021. Year of 2021. And this problem was the problem from the concept of differential equation. So let me do one thing. Let me bring this problem into the working board and we'll try to smash this problem in the working board itself. So here goes the problem. Let me read the problem carefully and then we'll try to sort this out. Consider the differential equation given below. dy by of dx plus of x divided by of 1 minus of x square of y is equals to of x getting multiplied with the root y. The integrating factor of the differential equation is, the four different kinds of the options were attached along with this problem. The first option was a 1 minus x square was raised to minus half. 1 minus of x square was raised to minus 3 by 4. 1 minus of x square was raised to minus 1 by 4. And the option D was 1 minus x square was raised to be minus 3 by 2. Probably this minus sign may not be visible to you guys. That is why orally I have communicated all four possible options. And it has been a type of MCQ. That means you will have only one appropriate most answer. My dear friends, would you able to recall when the concept of integrating factor comes into the picture? The concept of integrating factor comes into the picture when we deal with the Leibniz form of, just a minute, Leibniz form of first order linear differential equation. Yes. And once you'll see how the structure of the differential equation has been given, it has been given as a dy by of dx plus of x divided by of 1 minus of x square of y, and it has been x root over of y. My dear friends, once you will visualize this problem carefully, you will get to know this is not a form of a linear differential at all. So you had to convert this non-linear form of the differential equation into the Leibniz form of the linear differential equation. Once you are done with the Leibniz linear form of the differential equation, easily you can get its integrating function. How did we know that it's not a linear differential equation, or it is not a linear differential equation of a first order? My dear friends, if it would have been a linear differential equation, no. So the structure must have been dy by of dx plus of, this could be the function of independent variable, and here the independent variable has been x. How did we know about it? You yourself would be able to understand the y has been a dependent variable. That is why the differentiation of y has been taken place with respect to the independent variable, and that's nothing but the x. Yes. And here it could have been the function of x strictly. What is the p and x over here? The p and x could be the function of, p and q could be the function of x, and even they could be mere constant value including 0. But once you'll see this problem carefully, you'll get to know this form does not carry the component of x alone or the component of the independent variable alone. Obviously, it is not a form of Leibniz form of the linear differential equation. It has been Bernoulli's form of the linear differential equation. The guy who have studied a bit about the Leibniz linear differential equation or reducible to the Leibniz linear differential equation definitely must have studied about the Bernoulli's form of the linear differential equation, which is a form of reducible form to the Leibniz linear differential equation. So it is a Bernoulli's form of the Leibniz linear differential equation. That means although at first look this differential equation may not be looking as a Leibniz form of the linear differential equation, but after certain adjustment we can convert into the Leibniz form of the linear differential equation. May I know what would be your approach? This root y is the factor which is smashing my game. So what I would be doing, I would be snatching this root over of y out. How it's possible? Just by dividing root y towards left hand side as well as towards the right hand side. So what I would be doing, root y has been divided both other sides. So here it becomes y to the power of minus 1 by 2 dy by of dx. Similarly, here x divided by of 1 minus of x square would remain as it is, no change as such. Here the y was already there towards the denominator side, now comes y to the power of half. So y divided by y to the power of half would make it or would change it to y to the power of half itself. Y to the power of half itself, and now the right hand side is happy because it has been the function of x alone. It has been the function of x alone. In next step, what we would be doing, obviously we had to change this complete problem into this form. Maybe what I am saying, maybe the dependent function may not be y, it can be t, but the function or the differential form of equation must follow this structure. For that, what I would be doing, I would be keeping y to the power of half as t, y to the power of half as t. Differentiating both side with respect to the x now. So the differentiation of y to the power of half would become half into y to the power of half minus of 1, which will make it minus of half. Here it becomes dy by of dx is equals to of dt by of dx. dt by of dx. That means in future y to the power of half is ready to get replaced with t, and similarly y to the power of minus half dy by dx is ready to get replaced with 2 can come towards right hand side, 2 times of dt into dx. 2 times of dt into dx. Obviously we can replace now. See, let me slide this problem a bit. So what's the replacement would take place, my dear friends? If you'll see the dy by of dx, where, just a minute, yeah. dy by dx into y to the power of minus half can be taken as 2 times of dt by of dx. Yes, till this point each and everything is clear. Similarly, plus of 1 divided by of 1 minus of x square, y to the power of half has been taken as t. Y to the power of half has been taken as t. Yes, and it has been x alone. Yes, now the 2 can be shifted, and here we get the result as dt by of dx plus of 1 divided by of 2, 1 minus of x square, here goes t, and here goes x divided by of 2. Yes. Now as we were interested finding the integrating factor, how do we get the integrating factor? Now many of us must be knowing we had to integrate this function after raising over the power of e. So here it becomes e to the power of integration of 1 divided by of 2, 1 minus of x square dx. Anyways, we have calculated it thoroughly over here. You can see what was the most answer for this problem. What is happening here? Just a minute. Yes, the same thing was happening over here. See, so end of the day, we wanted to get this integration, and once we got the integration, what would the procedure? Again, 1 minus of x square would be taken as another variable u. Once you take the differentiation of 1 minus of x square, definitely you get 2 of u. End of the day, the result what we get after solving this problem, the answer is simply gonna be 1 minus of x square, and it was raised to minus 1 by 4. So till this point, probably each and everything must be clear to all of us. It has been a well-designed problem, and the problem was from the topic called differential equation. Just a minute. Yes. So let me go into the next question. So the next question of the day comes from the page number 19 of our corresponding PDF. Just a minute. It comes from page number 19. Here goes the next question. Yes, again it has been a problem. From the differential equation, and once you'll watch this problem thoroughly, you'll get to know we had to find the general solution, no, not general solution, particular solution for this second order of the differential equation. Obviously, it has been a linear differential equation with the constant coefficient. How did we know it's a linear differential equation? There is nothing yet multiplied with the derivatives of y as well as y, which has been a function of only and only constant. So obviously it has been a linear differential equation with the constant coefficients. May I know how do we calculate it? Whenever we find the general solution of the linear differential equation with the constant coefficient, it used to have the two part. The first part used to be complementary function, which would be calculated from the auxiliary equation of the given differential equation, and the second part would be pi, that's nothing but the particular integral, which would be calculated using the auxiliary polynomial as well as the input which was provided towards the system. So let me focus over this problem. At very beginning, let me bring this problem into the working mode. Yes, this problem goes towards the working mode. So before going to solve this problem, let me write briefly about the background of this problem. This has been a second order linear differential equation with the constant coefficient involved. Constant coefficient. With the constant coefficients. Yes. And at the same time, the value of y was given at 0, which is 1, and similarly worth of y at x is equals to 1 has been given as 3. That means once you read this problem thoroughly, the given informations which are supplied along with this problem and even the options, you'll get to know they have been talking about the particular solution of this given problem. Particular solution of this given problem. Till this point, probably it must be striking to each of the student. So at very beginning, I would be focusing over the general solution. May I know how we get the general solution of the linear differential equation with the constant coefficient? Yes, the dependent variable has been y over here, used to have the two part, the CF plus of PI, where the CF completely depends on characteristic equation of the given differential equation and Pi depends on characteristic polynomial plus of the input which was applied across the given system. Once you'll watch this problem carefully, you'll get to know there has been a case of zero input response. That means there is no physical input which has been connected across this system. So obviously Pi would not be present over here. Or if you want to recall, you can recall the general solution of the linear differential equation with the coefficient with the constant coefficient used to be complementary function alone if the type of linear differential equation is homogeneous in nature. What does it mean by the homogeneous in nature? The value of small r of x used to be 0. That means there is no input which has been applied in. So you just had to focus over the complementary function. I have just got the complementary function. We had to just focus over the complementary function, and once we are done with the complementary function, that's it. You can easily get the value of y. Yes. So how do we get the complementary function? At very beginning, we had to find the characteristic equation. How do we find the characteristic equation? First, the input would be forced to become 0. Anyways, in this problem, the input was 0, so nothing to do additionally. Now what I would be doing? I would be introducing a differential operator, capital D. For this problem, it has been d of dx. So once we start feeding these data over here, this differential equation can be written as d square plus of 2 of d plus of 1, and the y can be taken common, and here it gets compared with 0. Yes, no. Now I would be focusing over its roots. So you yourself would be able to understand the y can be shifted towards right hand side. The roots of this characteristic equation is gonna be d plus of 1 to the power of 2 is equals to 0. We had the repeated roots at minus 1. We had the repeated roots at minus 1. Yes, and if we have the repeated roots at minus 1, obviously CF can be easily calculated as C1 plus of C2x into e to the power of minus 1 into x, which is simply e to the power of minus x itself. And as it has been a homogeneous form of the linear differential equation, y would be equals to of complementary function itself, or y would be CF alone. Y would be CF alone. Yes. Now I am getting one input. Sir, I got 330 score CAC PWD category. Where should I apply? Here you can check the previous year cutoff in each and individual IITs as well as top NITs, because in PWD there are huge chances. So I would suggest to you specifically, if you have the PWD quota, you try to get the best or the best IITs. Yes, because sometime I have seen if their quotas are not getting filled, the people who used to get consumed in different IITs goes very low in score. Yes. So y would be equals to of CF. The CF is clearly calculated over this problem, which is equals to of C1 plus of C2x getting multiplied with the e to the power of minus x. And it has been the general solution of this linear differential equation with the constant coefficients. But as far as this problem is concerned, one thing is quite sure: the two additional informations are supplied along with this problem. May I know why these two additional information are being supplied? They have been supplied to get the precise value of C1 and C2. That means rather looking into the general solution, they are looking for the particular solution. So obviously at very beginning I would be feeding x is equals to 0 and y is equals to 1. I would be getting the equation which would contain C1 and C2. Similarly, next time I would be feeding x is equals to of 1 and correspondingly y is equals to 3. Comparing both of the equations, I would get the value of C1 and C2, and end of the day you will be getting the finalmost answer. Let me try it out. So the first information which I am feeding over here, y of 0. What does that mean of y of 0? The worth of y at x is equals to 0. If I keep x is equals to 0, definitely it becomes 0 itself, and the factor which has been remained over here, it is C1 e to the power of minus 0, which is C1 itself, and this value has been clearly given as 1. So in future, if I would be feeding the value of C1, I would be feeding the value as 1. That's done. Similarly, the second information which are supplied along with this problem, which is nothing but y at x is equals to 1. So here it becomes C1 is already known to me, which is nothing but 1. So I would be feeding as 1 itself. Why unnecessarily I will make this problem so complex? C2 would remain C2, and the value of x which would get multiplied with the C2 is simply 1. So it would be 1 plus of C2. And here it goes e to the power of minus 1 and has to get compared with 3. Yes, no? So what I would be doing over here, 1 plus of C2, E inverse can be jumped it to the right hand side. E inverse would become E towards right hand side. The 3 gets multiplied with the E, which simply be 3 times of E. So C2 is also known to me, which has been precisely 3e minus of 1. So the general solution what we had for this given linear differential equation was C1 plus of C2x into e to the power of minus x. The value of C1 has to be fed as 1. The value of C2 has to be fed as 3e minus of 1. Once you are feeding all of the data, you will be getting the particular solution for this given differential equation with this given initial information. So may I know what would be the value? C1 would be simply 1. C2 is nothing but 3e minus of 1, which is getting multiplied with x. End of the day, altogether it is getting multiplied with e to the power of minus x. This would be your best most answer. Could you understand? So once you will open up the complete curly bracket and once we will be multiplying e to the power of minus x separately, definitely the best most answer what we are getting for this problem is going to be simply C. So probably this problem should also be done to most of the people. Let me go into the next question. Yes. So let me go into the page number 27. So this would be the next question of the gate. Yes, sir, gate result is out. Yes, my dear friend, gate result is out. Yes. This would be the next question and probably fourth question of the day. So let me bring this problem into the working board. Here goes the problem. Yes. Try to read this problem carefully and then smash this problem out. It has been a sort of a very easiest problem. If k is a constant, the general solution dy by of dx minus of y by of x is equals to 1 will be in the form of the 4 different options were given along with this problem. Obviously, it has been a type of multiple choice question. Out of 4 number of options, only one option is going to true. The first option was y is equals to of kx ln of k. The second option was y is equals to of x ln of kx. The third option is going to be y is equals to of k ln of k of x. The D option is going to be y is equals to of x times of ln of x. May I know what are the datas cannot be the appropriate answer for the given problem? This cannot be the appropriate answer. Why? Because the ln is being applied over the k. Once you'll solve this problem, you'll get to know the log natural has to be applied over the function of x alone. It could be kx, it could be x, it could be x square. So obviously a could have been ruled out easily. Similarly, d can also be ruled out. Why? Because no additional information or no initial conditions were provided along with this problem. In that case, its solution would not be free from arbitrary constant. As it has been a linear differential equation with the order of 1, definitely one arbitrary constant should come into the picture, and which was not there with the option D. So the A as well as D has been ruled out. So you have been left out with the option B as well as C. We'll try to understand, or we'll try to judge which would be the best most answer. Again, recall the differential equation which has been provided along with this problem, which has been dy by of dx minus of y divided by of x is equals to of 1. Anyways, just by visualizing or just by watching this differential equation, would you able to figure it out whether it's a form of Leibniz form of the linear differential equation or not? Obviously, yes, it is. It has been a Leibniz form of the linear differential equation. Yes, it has been. Yes. If you'll compare with the standard structure of the Leibniz form of the linear differential equation, how used to be the structure of it? It used to be dy of dx plus you can have a function of x alone which is getting multiplied with a dependent variable, and here in this problem it has been y, and towards right hand side you can have only and only a strict function of x alone including constant. What does that mean by the f of x and g of x? They could be the strict function of the independent variable alone including constant. Now, once you'll compare both of them, instead the dy of dx, obviously we also had the dy by of dx, y was common over here, and minus 1 upon x has been in the place of f of x. So f of x has been minus 1 divided by of x. And similarly, 1 has been in the place of g of x. So obviously even the g of x has been 1. And whether it is meeting my requirement, obviously sir, it is meeting my requirement. It has been a pure function of x alone, and even it has been a pure constant. It could have been even the function of x also. Yes sir, it is meeting my requirement. Obviously it would be categorized under the Leibniz form of the linear differential equation. How do we get the general solution from the Leibniz form of the linear differential equation? Towards left hand side we used to have dependent variable. In this problem it has been y, and here we used to have multiplication of the integrating factor, and here we used to have y integrating factor getting integrated over the x domain plus a arbitrary constant, and here it has been clearly visible that it has been k over here. It has been k over here. It has been k over here. So till this point probably each and everything must be very well aware to all of us. Now let me focus over the new factor which have arrived during its general solution, and that is nothing but if, which is also called integrating factor. How do we calculate the integrating factor? Just focus over the f of x. The f of x used to be raised to power of e, and then we take its integration. So simply it becomes e integration which has been raised to e minus of integration of 1 upon x dx. Minus of integration 1 upon x dx. May you know what used to be the integration of 1 upon x? It's a well-known factor which is e to the power of minus log natural of x. Now this could have been written as ln of 1 upon x or x inverse, and e and ln would be knocked each other off. The factor which would be left out is simply going to be 1 upon x. The factor which would be simply left as 1 upon x. 1 upon x. Yes, 1 upon x. So the value of integrating factor is clearly known to me. Any mistake has been taken place? If it is so, you can cross check over here. 1 upon x, ln of x, ln of x. No, everything is fine. Everything is fine. So let me focus over this general solution. The integrating factor is known to me, which has been 1 upon x, has to get multiplied with the dependent variable which has been y over here. Then we would be taking its integration, the integration of y would remain as it is, and here you will be having this I of f. Just a minute, mistake has been done. Here we used to multiply, we used to integrate with g of x with the integrating factor, no, dx plus of c. One mistake has been made. May I know where it is? Yes, it is not y actually, it is g of x. It has been g of x. Yes, so here it becomes 1 upon x g of x. Tell me what would be the g of x. The g of x is being 1, you can see over here, and similarly integrating factor has been 1 upon x. Integrating factor has been 1 upon x. Yes, 1 upon x. You would be able to get the exact or the precise most answer for this given problem. Tell me what would be that answer. So you had to get the integration, and at last you had to get the final value or the final verdict of it. So here it would be y divided by of x. The integration of 1 upon x would be simply ln of x, and here it would be k. For the simplicity, what I can do, this can be taken another constant as a ln of k. My dear friends, it has been an arbitrary constant. I am not saying the value is known, but just to finish this problem into the simplest form, what I did, I took this arbitrary constant in the form of log natural. Till this point, probably each and everything must be clear to all of us. So here the factor which comes in mind is going to be y divided by of x. Ln of a plus of ln of b used to be ln of a into b. The k gets multiplied with x. So the y which we get out of this calculation is simply equals to of y is equals to of x getting multiplied with the ln of k into x, So what would be the bestmost answer? The bestmost answer is going to be option B. Yes, could you understand each one of you? Now let me briefly discuss about the few of the important properties of the log. Yes. If I say, just try to understand, if I say log base of, for the time being I have taken a itself. Why I have taken a itself? Because it would be covering the broader sense. Even the a could be e, a could be 10, a could be 2, a could be 4, a could be 8, so on and so forth. If I say log operation has been applied over a variable x and the result has been found as y. What does that actually mean of it? It means that the x has been a to the power of y. A to the power of y. Yes, repeat. Should I repeat it once again? That has been, x has been a power of a to the power of y. A to the power of y. Yes. Yes, my dear friends. Now, few of the important conclusions which we can retrieve out of this. Just try to understand what they are. If I take square both of the side, keep in mind it would become x square and it would become a to the power of 2y. Agreed. And now if you'll take ln both of the side, it would be simply ln of x square is equals to of. See, a to the power of y has been x over here. What I am saying, a to the power of y has been x over here, and here it has been a to the power of 2y, which can be simply written as x. So here it simply becomes 2 times of ln of x. Yes, 2 times of ln of x. There are several different important properties which we can deal with the ln. Many of the times I have seen the student used to have a doubt, sir, why the log cannot be applied over the negative value of x? No, it can't be. My dear friends, this value of x cannot be negative at any fraction amount of time. Why? See, if you say the x is negative, for which the log operation has been applied, virtually you are saying the x is equals to of a to the power of y, where the a has been a positive value. May I know what the worth of y you would be keeping for keeping x as negative? No, you cannot keep any possible value of y. If the a has been a positive value, let's take a has been a 2, you can keep minus 2, you can keep plus 10, you can keep minus 20. In all of the conditions, result what we would be getting out of this would always be a positive value. Yes. So till this point, probably each and everything must be clear to all of us. The answer is also clearly known to me, which was option B. Just a minute. Let me move into the next question. The next question comes from the page number 30. Here comes the page number 30. Yes. Once you'll see this problem carefully, you'll get to know again it has been a problem of Leibniz form of the linear differential equation. If y of x satisfies the differential equation, sin of x dy by of dx plus y of cos of x is equals to of 1, subjected to the condition y at x is equals to pi by 2 has been pi by 2, then I need to find the y at pi by 6. Obviously, it has been a problem of Leibniz form of the linear differential equation. With the help of Leibniz form of the linear differential equation, we had to find its general solution. By feeding y at x is equals to pi by 2, you had to find its particular solution, and with the help of particular solution, by keeping x is equals to pi by 6, you need to get the value of y over here. So may I know what would be your line of treatment for this problem? Anyways, the sine of x has to be knocked off towards right hand side. It would become cos of x divided by sine of x. Similarly, it would become 1 upon sine of x. That's nothing but the cos of x. Cosec of x, which we have been doing so far. Yes. So straight away, let me jump into the problem. I would try to arrange this problem into the standard form of the Leibniz linear differential equation, which would be dy by of dx plus here goes y cos x divided by of sin x. Deliberately I am not writing it cot of x, because in future we had to take its integrating factor, and calculation of the integrating factor of the cos x by of sin x is easy. So I am keeping as it is, and here it goes 1 upon of cos of x. Yes, not cos of x, sin of x. So till this point, probably each and everything must be clear to all of us. While process of calculation of its general solution, we get the integrating factor first. What used to be the integrating factor? The integrating factor used to be the integration of this component raised to the power of e. So here it becomes e to the power of integration of cos of x divided by your sine of x dx. What would be my approach? At very beginning, I would be keeping sine of x as t. Once I would be feeding sine x as t, the differentiation would become cos of x into dx. Cos of x into dx would become dt. End of the day, it has simply be 1 upon t into of dt, which has been e to the power of ln of t. Ln of t, which is been simply t itself. Which has been simply t itself. May I know what was the t? The t has been referred to sine of x. So it has been simply sine of x. Sine of x. Now once we are done with the integrating factor, now it's time to get the general solution. What used to be the general solution? The y would get multiplied with the integrating factor, which has been sine of x. Sine of x. Similarly, towards right hand side, there would be the integration of g of x. What has been the g of x? Which has been 1 upon sine x itself. 1 upon sine x. Getting multiplied with the integrating factor, which has been sine of x again over dx, and here you will be having an arbitrary constant k. How many number of arbitrary constant would be there? After general solution, obviously 1, because the order of the system has been 1. If the order of the system has been 1, that means you have smashed only one number of arbitrary constant. So here goes the next calculation. Y gets multiplied with the sine of x, no change. Sine x is going to knock off. So there would be the integration of 1 itself. The integration of 1 is simply going to be x, and here goes k. Here goes k. So it has been the general solution of this given first degree of Leibniz form of the linear differential equation. Linear differential equation. Now what I would be doing over here, it has been precisely given at x is equals to pi by 2. It has been found the value of y was pi by 2. So what I would be doing, my dear friends, y sine of pi by 2 used to be 1 is equals to, just a minute, at x is equals to of pi by 2, sine pi by 2 used to be 1, and there the value of y which has been found as a pi by 2 is equals to x is already been pi by 2 and plus of k. When the pi by 2 goes towards left hand side, they would be smashing each other. The value of k was got to be 0. The value of arbitrary constant with the help of initial conditions which were supplied along with this problem was found to be 0. So obviously we can find the particular solution, which would be equals to of y times of sine of x is equals to of x, and this is gonna be the particular solution which was calculated with the help of linear differential equation and its initial condition which were supplied. So let me calculate the value of y at x is equals to pi by 6. So here it goes, pi sine pi by 6. Nobody should write this as a 30 degree. No. If you are writing x is equals to of 30 degree, you are done. My dear friends, see why I cannot write x in degrees. See, if x is already been dealt inside the trigonometric function, no, then it's fine to take either in degrees, either in radians. But once you'll see its right hand side, you'll get to know the x were not dealt within the trigonometric functions. They have been dealt as a sole function. In that case, you cannot deal with the degrees. If the time permits, definitely I would be discussing why not I can go ahead with the degrees. So here it becomes pi by 6. Sine of pi by 6, what used to be the worth? It used to be 1 upon 2. So the value of y, what we get, it's going to be 1 upon 2. 2 would jump towards right hand side. The result what we would be having is simply going to be pi by 3. Simply we would be having as a pi by 3. So the best most answer for this given problem is simply going to be pi by 3. Yes. Anyways, I would end my session here itself. We would be meeting with a continuation of this engineering mathematics precisely at 9 p.m. tomorrow, and the span of the hour which we used to have in daily basis, that used to be 1 hour. So tomorrow also we will be taking around 1 hour. I would like to take one feedback from each one of you. Once we are done with all previous year 2021 questions, should I be starting the engineering mathematics from the very basis? If the answer is yes, just write yes over the live chat, so at least I'll have the idea what should be my next plan. So I would start from the very basics of the engineering mathematics. We'll start from the polynomial, we'll start with the residues, we'll start with the important logarithmic functions, we'll start with the important sinusoidal as well as trigonometric functions. Once you have the fair idea about the graphical understanding of the each and individual functions, you would be able to deal the mathematics in the great ease, Tell me. Anyways, Krishna Kumar is saying yes, sir. No, definitely you are going to enjoy that video. There is no doubt at all. I know many of the students may not be enjoying this video because taking the help of the previous year questions, we are building the concept for the year of 2022. But once we start from the very basics of the engineering mathematics, you are bound to like that video. There is no doubt as such. Anyways, the V Krishna Kumar have said yes. Okay, my dear, we'll try to do so once we are done with all of the questions which have appeared from the engineering mathematics year of 2021. And yes, the result has been announced. So you can check your result, and all the very best if you have scored very good marks in GATE, and if you could not score very good in GATE, still I would say no issue. Keep fighting, because the life is meant for fighting, and the spirit of life itself is fighting with a great pace. Okay then, for today, this is all. We would be meeting with the same passion, with the same concept of the engineering mathematics precisely at 9 p.m. The class would end around 10 p.m. Bye-bye. Take care. Good night.